All right, so we're starting off here. We're looking at relations versus functions. So I'm just going to kind of look at reading the first part of the note. Again, I'm not going to copy it down, but I'm going to read it. And here's the key: is a relation is a set of data. So it's points, just points on a graph that you can plot, obviously. All right, so data, you have an x and a y coordinate. That's your relation. Now, we're going to look at two things today. First off, is that relation a function? All right, and I'm going to explain as we go along here. This is a bit of a wordy note and a wordy lesson here today, but I'm going to explain everything as we go along. But a relation is a function if, number one, if you do not have a graph, for every x coordinate, there is only one y coordinate. But if you do have a graph, number two, no points can be connected by a vertical line. No 2 points can be connected by a vertical line, which is called the vertical line test. All right, so that's the first thing we're going to look at with different relationships is it a function or not? Now, here's the second thing we're going to do. There's a property of a function or a relation is the domain. And the domain is the intervals or values of all the possible x coordinates. The range, which is next, is the same thing, only now we're talking about the y coordinates. So it's the intervals or values of all possible y coordinates. So here's what we're going to do today. I'm going to go through 8 relationships. I'm going to determine whether they are a function or not, and then I'm going to find the domain and range for all of those functions, or all those relations, I should say. I'm not sure if they're all functions. All right, so my first example, and again, these are the same examples as the note I put on Google or on the website. All right, so our first relationship here is we have a table of values where we're measuring the altitude and the temperature. Now, anytime you have a table of values, the table on the left is your x coordinates. The table on the right is your y coordinates. All right, so the first thing I want to do, and again, it takes a few examples to get a hang of this, is I want to determine if this relationship is a function. All right, now I don't have a graph, and so what I'm looking at is, first of all, is there any x values repeated? And there isn't. And so, again, it's going to take a couple examples, but so in this case, this is a function. And the reason, which you are going to have to state on tests and quizzes, is that for every x, there is one y. All right, that's the reason for why it's a function. Now, here's the key, why we want to know whether a relationship is a function or not. A function is all about predictability, all right? What I want to know in this situation is if I'm at a certain altitude, this is the temperature I'm going to get. That's what makes it a function. Predictability. Now, is this data set huge? No. It's probably not a very good experiment to say that. But again, that's the idea of a function is predictability. If I get this x value, I'm going to get this y value. Things get mixed up when that doesn't happen. So we'll get to that. Now, the second thing is the domain. It's all the possible, and I'm going to show a little notation here. So I got a D, little not semicolon, colon, and with a little squiggly brackets, and it's all the possible x values. So when you're doing an experiment is which x values did you measure? Well, I measured at an altitude of 0, an altitude of 100, 200, 50, and 150. Now, I didn't have to write them in numerical order because all we're doing with the domain is we're listing. We're just saying, hey, these are the measurements we took for the x values. The range works the same way. So big R, we got a colon there. And let's see here. What temperatures were measured? We got 10 degrees. We got a 12 degrees, a 15 degrees, an 11 degrees, and a 13 degrees. And there we go. So what I did was I found out that this was a function by analyzing this particular data. Here are the possible x's. Here's the possible y's. All right. So again, I'm going to throw every different scenario at you here. All right. So I get to B. Let's have a little line here. B. Again, this is measuring hair length and height. All right. Now, so I want to see if this is a relation or a function. So I check out my x values. Do I have repeats? I do. I do have repeats. That doesn't necessarily mean it's a relation. What are the values? I got 180 and 176 for x equals 15. So that's going to make it a relation because it isn't predictable. Because for x equals 15, the y is equal to, what do we got? Two answers, 180 and 176. Again, the idea with a function is you want predictability. Well, if I'm measuring the hair length and height, there isn't predictability given this data set because I have a hair length of 15, but yet the heights are different. And naturally in real life, right? Does hair length predict your height? Not at all. Otherwise, I would try to grow my hair a lot longer, which I can't, so I could be taller. That's not happening. All right, now again, now I'm on to the domain and range. What are all my possible x values? Okay, well, I had 22, I had 30, I had 15, I had 4, I have 6, and I got a 15, but I already said that was possible. So I'm not going to write 15 twice because all I'm stating is what is possible. Well, 15 is possible. I don't have to put it twice. All right, same idea with range. All right, what are my possible y values? I got a 172, a 180. Again, I got 180 again, but I don't need to write it again. 170, 174, and 176. And there we go. All right. Any questions so far at all? I'll do a little color switch. I can see your chat if you're, no questions? Nope, everybody's good. All right, so far. Okay, so now we get to the next one. C, where we have a set of data. So I kind of wrote the points not as a table of values, but as points. All right, and the x-coordinate represents the month of the year. The y-coordinate represents your average temperature. All right, so I look at this data. So I got the first point here is 1, -18. That means in January, that's our first month, the average temperature is -18. Kind of like it feels like out there today. So again, I'm looking at, is this a relation or a function? And I look at repeating x values. There is none. So this is, as far as we know, a function. For every x, there is one y. All right. Now we get to domain and range. Now here's something with the domain and range. I'm looking for all possible x values. Now usually when I'm in class, I throw this out there and I say, can somebody tell me the domain? And most of the time they'll say 1 to 6. That's not right. 1 to 6 means every number between 1 and 6. 1.22222, 3.4, 5, 6, 7, 8, 9, 10, 11, 12. I don't know. You know all the numbers. That's not true. So the domain is number 1, number 2, number 3, number 4, number 5, and number 6. That is the domain. And again, we're going to see when you have all the numbers, we're going to get to those kind of examples. They're coming. All right, range. What are the possible y values? I have a -18. Again, I have another -18, but again, with the range and domain, you're just stating what's possible. So I don't need to repeat it. I have a 5, a 10, a 16, and a 20, 22. There we go. And so again, I've determined whether it was a function or not. There's the domain and there's the range. All right, now I got another example here. I couldn't fit it on. Just give me a second here. So that's 2 table of values. We got some points there. Going to do something a little bit different. All right, and that is what's called relation bubbles. All right, so this is example D. All right, so again, I'm going to be looking at 2 relation bubbles. It's another way to illustrate a relationship. We have a table of values and points. All right, so I have X over here, which is eye color. All right, so because of relation, I should draw the bubble after because I don't know how well I can draw. So this is the blue eyes. We have green eyes, brown, and hazel. Those are our 4 eye colors that we're looking at. And then we have Y over here, which is your batting average. All right, so we have a 280, not bad, 300, a 318, a 320, and 340 down here. All right, there we go. There's my nice bubble. And again, I got to connect the dots here, connect the lines. All right, so I have, let's see here, blue is going down that way. Green we have going this way or this way. Brown going there, and hazel going there. There we go. All right, so you know what? I'm going to erase over here because I'm going to need that space. Does everybody want to take a shot and tell me whether this is a relation or a function? Assuming you're not looking at the completed note. There we go. Get rid of that. There we go. All right. So anybody want to take a shot at this? Is this a relation or not? Or is, sorry, it's definitely a relation, but is it a function? Relation, okay. Why is that? Why is that a relation? No predictability, that's true. Now I want a specific example of why it's not predictable. And so what I would write, or need to write, is it is, you guys are right, it is a relation. And the relation is for X. What makes it unpredictable is for X equals green, Y is equal to 280 and 320. That is why it's a relationship, all right, and not a function, because your eye color does not dictate what your batting average is. Now, I actually did this example. I created this example many years ago, but they came up with an experiment that I showed that actually eye color does affect your batting average. In the major leagues, they found that people with bright eyes struggle during the day. So there's actually was a relationship. So now again, for domain and range, I want possible X values. So possible eye colors. Well, we have blue, green, brown, and hazel. There we go. So there's our 4 possible X values. For new baseball fans, it doesn't include Max Scherzer. He's got 2 different eye colors. I think he's got hazel or brown and green. Let's see here. Now, relation, what possible Y values are there? We have a 280, a 300, a 318, 320. But I'm not going to write 340 here because even though I've got it in my relation bubble, nobody hit 340. All right, so because it didn't happen, I'm not going to put it in part of my range. So there we go. So this is a relation because it's not predictable. We had 2 people with green eyes and they batted there was 2 different batting averages, so it's not predictable. All right, so now that's determining if each relation is a function and finding the domain and range. Now what we haven't done yet is graphs. So my next examples are going to be all about graphing, using graphs. All right, so let's see here. Again, I got to get that. Erase this. Determine if each. I'm going to replace that with graph. All right, so let's see here. I'll try to fit 2 different graphs. So Again, this is going to be example 2. We're doing the same idea, but we have different things. So determine if each graph is a function and find the domain and range. So we go with A here. So I got my first graph. Let's see here. Just a nice little sketch. So here's my graph. And hopefully, as you know from a parent graph, what I'm going to draw here is a parabola, a quadratic function. There we go. All right. So the first thing with what we're looking at here with the graph, again, I want to determine if this relationship is a function. Now I'm going to go back to the very beginning of the note I had right at the start here. And for a graph, it says no 2 points. It is a function if no 2 points can be connected by a vertical line. Well, a vertical line is up and down, right? And so if I use my marker, it only hits once, only hits once, only hits once. I can't find anywhere on my graph where it's going to hit twice. And so that makes it a function. And that's because it passes the vertical line test, which is a very simplistic way for math people to describe it. It is a vertical line. We use that to test it, and that makes it a function. So if it hits twice, that makes it a relation. All right, now the domain and range. Now this gets the relationship and the function part for graphs is easier, but the domain and range, a little bit tougher. All right, now what I want to look at is all the possible x values. Well, this parabola goes all the way to the left, and it just keeps going up and up and up and up. As it goes up, it keeps going left. Same thing on the right. As it goes up and up and up and up and up, it keeps going to the right. Every single x value is involved. Now, there's 2 ways to show that. You can go all real numbers. That's one way to show it, where you have a little r, or an r with a stick on the side of it. All right. Or I don't mind if you write all real numbers. There's two ways to say that. So every single number, every decimal. If I went 3.545, it'd be somewhere in there, and I could go up and find a y value. And because it's a function, there's predictability there. I know what I'm getting. All right, now the range. That's all the possible y values. So now we're talking about up and down, vertical, right? Well, this thing starts at 2 on the y-axis here, and then it goes up on the left, and it goes up on the right. But it never goes lower than 2, and it keeps going up, up and up and up. So because I'm talking about the y values, I write y is greater than, but this also touches 2. So it's greater than and equal to 2. So that includes every single number from 2 and upwards. All right, any questions about that? Check the chat. Okay, all right, we're looking good. All right, so B, let's try another graph. Again, the more you do, the better, the more easier it gets. Let's see, so I got another graph here. And I have, that's a nice linear equation here. It starts at x equals -1 and just shoots like that. There we go. So there's our graph. An arrow, here's something key. When you see an arrow on the end of a graph, that means it keeps going. It doesn't stop, it keeps going. So some graphs you'll see, they have arrows and some don't. All right, so that's the distinction. All right, so again, if I look at my graph and I'm just trying to determine whether this is a function or a relation, I look at the vertical line test because I have a graph. All right, and everywhere I put my marker, which is vertical, it only hits once. So again, this is a function. And again, you have to explain why. All right, it passes the vertical line test, but I'm going to passes the VLT. All right? So it passes the vertical line test. Now we get to the other part, the domain and range. Now this one started down here at -1, right? Because the domain, again, you're talking about left and right. There is no arrow there on this linear equation. It just stops there, but it then shoots up. But it starts at -1 here, and then it moves to the right. And so because with the domain, I'm talking about the x values, I can say it's greater than or equal to -1. All right, my y values, which is the range. All right, so this thing, again, we're talking about up and down with the range. It starts here at the bottom at 0, and then it goes up. And so that means my y values are going to be greater than or equal to 0. And there we go. All right, let's see here. C. Oh, this is a tough one. Okay, C. It's going to be a tough one for you guys to see, I think. So let's wash this off. What's nice space here? Nice and dry, so it doesn't wreck my markers. There we go. Okay. All right, so now we have a different graph here, different type of graph. So we got C. So we draw this. And this is where we're talking about goals scored on the y-axis. And down here, it's games played. All right, and so let's see here. Just mark things off. I'm going to do exactly like the lesson on the website here. So I got a dot here. Whoops, I better get these in here. 1, 2, 3, 4. What are we going up to here? Ooh, 6. Okay. All right. So I got 2 here, 1 there, 1 there, 1 there. 4 games played, and you have 5 goals. Sign them up. All right. 5 games played, 3 goals. Okay. 1, 2, 3, 6 dots. All right. So I'm talking about 6 different players here, where we're looking at how many games played, graphing how many goals they scored. All right, now again, I want to see if this is a function or not. So I'm going to, because I have a graph, use my vertical line. All right, so I go here on 1 game played, only hits once. But when I go on 2 games played, it hits twice. All right, it hits this dot and this dot. And so that means this is now a relation. And that's because it fails the vertical line test. All right? Because again, it's got to be, it is a relation in this case because there's no predictability. I can't say that if some player plays a certain amount of games, this is how many goals they're going to score. We don't know that. All right? Now, here's where this becomes a little different in the terms of being a graph. The domain. What are the possible X values, right? The games played. And again, this is where I'm not going to say 1 to 6 because that's impossible. You can't play 2.5 games. You might say that you play 2.5 games, but if you look on any professional sports sheet, you either played or didn't play. You might have got benched after 2 periods or something, but you were in that game. As soon as you step on the field, the ice, whatever it might be, it's counted as a game's play. So if I look at my graph, yep, somebody did play 1 game. So there's one possibility. 2 people played 2 games. Nobody played 3 games. So I'm going to leave that out. Somebody played 4 games. Somebody played 5 games. And somebody played 6 games. There's our possible X values. All right. Now, the range. Possible Y values. Well, 2 people scored 1 goal. 1 person scored 2 goals. 2 people scored 3 goals. And nobody scored 4, nobody scored 6, but somebody did score 5 goals. And there we go. So there is, we found out this is a relation. it's not a function, and here's our domain and range. All right, our last example, good old D here. Again, a different scenario. So I want to make sure I do it right. So I go 1, 2, 3, -1, -2, -3 here. This one's going to go up to 5, height of 5, and then down here, 3, 4, down to -5. All right, so there's my graph. And this thing is going like this, like an upside down football, I guess. There we go. All right, so the first thing I want to look at, again, determining whether this is a function or if this relation is a function. So I got my vertical test out here, my vertical line test, and I look and it hits twice right there. And in fact, if my pen was larger, it hits twice everywhere on this graph, except for maybe at the very top and the very bottom. Well, actually, no, it has to hit twice everywhere, doesn't it? All right, so this is a relation. And again, it's because it fails the VLT. Fails our vertical line test. All right, now, the domain. All the possible x values. Well, this graph starts at -3, and it goes all the way to 3. And we have every possible value. We don't have any dots here. And so it's from -3 to 3. So to write that, I say two things. X is greater than or equal to -3, but it does have an upper limit. So X is less than or equal to 3. All right, so it's got both a lower limit and an upper limit. Same thing with our range. All right, so I look, again, that's vertical, our range, our y values. It bottoms out here at -5, but only goes up to 5. And so, again, because we're talking about range, our y values, it's greater than or equal to -5, but yet y is less than or equal to 5. And there we go. So again, all we're doing for day one here, well, not all we're doing, lots going on here. There's a lot of different scenarios here. We're trying to figure out if each relation is a function and then state the domain and range. Some examples we have no graphs, some examples we do have graphs. All right. So I'm just going to hit the stop button.